And hello, welcome everyone to this video of OpenFOAM and C++. Today we're going to do something very interesting. We're going to try actually compiling our own solver, and well, we're going to make it do some simple things or really dumb things. Okay, not really dumb, but at least just get ourselves acquainted with the wmake script so that we can start compiling our own solver. Of course, you're not going to make it do somersaults or anything like that, but we want to at least, let it, maybe print a few extra lines of code, say hello, or say something really dumb. I don't know, whatever. Okay, so that's the idea of today's video. We want to try doing some of that, and at least try looking into some of the knowledge that helps us get there. Now, I do not cover all of C++, but I just want to cover just enough so that you won't get lost when we start going through this compilation process. All right. So this is stuff from CFD Direct. I think it's part of the OpenFOAM Foundation. Like where you have OpenFOAM 6, 7, 8. All of these are OpenFOAM Foundation stuff. And they have a pretty nice documentation when it comes to this compilation of applications and libraries. Okay. So actually, to start us off, we want to understand how this whole compilation process works and how wmake comes in. So this is the source code for wmake, which I won't go through. I'll only go through how to use it, and I'll be referencing this compilation libraries and applications. Okay, that's one. And of course, I will also look at this tutorial here, how to copy and recompile icoFoam. Though the solver I'm doing today is not icoFoam, it's actually well, I'm going to make buoyant pimpleFoam, do a few simple things. I'm not going to get it to I'm not going to add temperature to icoFoam just yet, though this is one of the classic tutorials that we probably want to do. I just want to make buoyant pimpleFoam, maybe print a few extra lines of text, and then rename the whole thing. Yeah, so I'm just going to rename the whole thing. Okay, so that's the idea of what we are trying to do here. Okay, we'll try and follow this tutorial, but we want to make buoyant pimpleFoam do something else. Okay, so let's walk you through the compilation process first. So how we deal with classes in separate files, in header files, and what have you. So apparently over here, the codes that are written by OpenFOAM, they use the C extension rather than the C++, though in actual fact OpenFOAM is written in C++. But anyway, this is a very small thing to take note of. We usually, in OpenFOAM, they like to use capital H and capital C to denote their functions and their classes and everything. All right. So how is this code being compiled? Of course, you have to use this compiler called wmake, and it's kind of native. It's native. It can be used in other applications, but it works for OpenFOAM. All right. So it says here, to first understand the compilation process, we need to understand certain aspects of C++ and file structure, blah 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 blah. We've already explained that in the last few videos, most of it anyway. There's one extra bit here that I did not go through, but I guess I'll just go through it, like maybe explain in 10 seconds kind of thing. Okay, not gonna go very long on it, because we want to get our hands dirty. That's the idea. Okay, so remember we have a class. If let's say this class is called NC, maybe that stands for new class. That's how it looks to me. Okay, we have an NC class. We have our definition in our header file, our prototyping, and we have our C file or C++ file, which will tell you all the functions that you're supposed to do inside this file. All right, so this is like the in-house, right? So the only thing you need to do in your main code Alright, in your main code, you only need to have your header file there. One example here is a buoyant pimpleFoam. So in your buoyant pimpleFoam, you will have this int main file, and then you have your classic return 0. Of course, the solver will do all these things and run all these classes and functions here. Okay, but where do all the functions come in? How do you add this functionality? You see all these include files here. Okay, this is how you actually give it all this extra functionality. Alright, so that you can have it. Alright, you'll notice that a lot of these includes are not available within the same folder here. So they are actually located elsewhere. But don't really need to worry too much about that, because wmake will actually just take care of everything for us, so long as we structure the file correctly. Okay, so that's that. Okay, so this is where your main so-called your int main is, and then all your header files are more or less over here. Okay, all your header files are here. So these are where your header files are. Though of course you don't see this the header guards, the if and def, and then you have your define and end if. These are not specifically defining a function, but you're like rather just running a line of code. So you notice that these header files can be used to encapsulate sections of code. Alright, so to speak. So you have equation.h, and this is actually just setting up a few equations, running a few functions, and yeah, you see all of this actually they are just running functions within the class. So and this is roughly just setting up the matrix. Okay, so this is actually just setting up an equation and solving it. This is what the equation.h is doing. And of course you will find all of these files somewhere else. They're not in this file. Okay, so then you have the uequation.h. Same more or less. You have your files here, but again you see that your main class files are actually existing somewhere else, not over here. All right, so you see your include. Whenever you see this include uequation.h, include equation.h, this is where buoyant pimpleFoam starts to solve all of these things. Okay, so that's how the pimple loop works over here. All right, then you have your row equation.h as well. So if you want to see what that does, you can go elsewhere. I think the row equation.h is not exactly placed here. You'll probably have to find it somewhere else. Okay, so anyway, that's enough of that. Alright, so basically when you have a main code, you can go and compile everything, but as you see, most of the files there, they are not within the same folder, so they actually have other binary files that they are linked to. So this is the new concept called linking. Okay, so OpenFOAM will have a set of libraries, a set of pre-compiled binary files. Notice that this thing is called SO instead of O. Okay, so these files, we use .o files to state that they are objects. So if I'm not wrong, these are called static objects. But basically they are just we have those O files there. Remember, we had our make files. We had our make file here. We have all these O files here. Alright, all these O files. This is an object file. I think SO actually stands for static object. Alright, but basically it means that you can execute these binary files anytime during your runtime. When this code is running, you don't need to combine these two O files together. Normally we combine these O files together, but you can actually keep them separate if you use this linking, so that if this is your main file and you want to call your vectors file or vectors object when it's running, you can use this linking method. So this is one way to get around, always having to combine all the libraries together, all the objects together into one binary file. You can actually make your binary file dependent on other libraries by doing this linking, so that you don't have to make huge binary files for yourself. Okay, so this is roughly what it is. It's like keeping binary files separate, making sure that they are like dependent on each other, so that if you have a group of solvers that use certain common functionalities, such as maybe all of them like to solve the velocity equation, so you use the U equation, and that's probably one of your common libraries. Okay, so that's one way to solve it. I'm sorry, I think it took a lot longer than 10 seconds, but okay, that's roughly what it is. I'm not going to explain so much. Okay, so these are the header files. Remember, we can use header files to define classes, or we can use them to actually run lines of code, as you see in your U equation and E equation there, so to speak. Yeah. So we are actually running lines of code. We are actually solving. We are telling the solver. We're actually running functions within this U equation.H. So that's, or is it running classes from the objects, which are actually functions. Well, there's a lot of jargon there, but yeah, basically it's there to do that. It's there to include certain classes, and of course, when you want to call classes as well, that's fine. Okay, so that is what the header files are usually there for. Okay, so now how then do you structure a new solver, right? Let's say you want to edit a solver. So likely is that the most likely way of doing it is to make a solver, copy an existing solver and just edit it, just like what we are trying to do here. Okay, so how is this new solver how is each file supposed to look like? Okay, we have let's say you want to have a new application. Let's say we call it Dummy Buoyant pimpleFoam, for example. The new app is called Dummy Buoyant pimpleFoam. So I will have a Dummy Buoyant pimpleFoam.c, and we'll have a collection of other header files. And then within this new application, all of this must be in the same folder, right? New app.c, or Dummy Buoyant pimpleFoam.c, and whatever other header.h. So what else you need there? You'll need a makefile as well, and this will be files and options. So the makefile, well, we don't have one make script like a makefile. We have a make folder, and inside that folder we have files and options. So wmake kind of works slightly differently, or very much differently from what we are used to in the make, but the instructions for how to compile are based within this make folder. Okay, so what are these folders here for? Okay, so let's take a look. One of them is you tell the compiler, which is wmake or make. Yeah, one of the purposes of having this make folder here is to tell wmake the directories of all your other header files and where you're supposed to find them. Okay, so where will these directories be? They are listed over here. You either have it under your source, the wm project directory. Wm stands for wmake. So your wm project directory is, well, if you do a simple, okay, or you cd to the main, if you just start your Ubuntu or whatever, your Linux, okay, and you cd wm project directory, right? You will go to your place where you find your tutorials or blah blah blah, or you can even type foam and you'll do the same thing. Okay, so that's what it is. Okay, it will look over here into your source OpenFOAM ln include. So it goes to source, Okay, OpenFOAM and then the ln include. So this is where you will find a lot of your C and H files. Alright, so let's say I want to look at this thing called listops.c via listops.c. Alright, and then you will see the C++ file here all being done. So this is one place you can look for libraries. Okay, the other place is inside a local ln include library under the new app ln include, and you look in the so if you have a new app file, a folder, you have your new app.c and other header.h, you can put your libraries under a local library called ln include. It's for include during including your headers. So you can make another file just beside your make file to be a ln include, or you can put it in a new app or blah 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 blah. Okay, so these are some other directories here. Okay, so you can either put it in platform dependent paths blah blah blah, or you can actually specify under your make options over here. So this options actually gives you a place where you can actually specify a custom place for you to put your header files and of course your C files as well. Alright, and then your libraries, which again I was saying here, you have all these static libraries where you have pre-compiled binary files which your application can call on during its runtime. So when let's say you have your new buoyant pimpleFoam dummy solver, you can actually call on a shared list of binaries or libraries when it's running. Okay, so where does it look for these libraries? It will look in the foam library of binaries. So if you go to if I do cd foam library binaries, you look at the things here, so you have a lot of these SO files here that you'll be looking for. Okay, so if I go and look in one of these, it will likely be vi lib with models.so. Yeah, if I go and vi one of these, it will all be binary. Nonsense, you cannot read it at all. So just don't bother trying to read. Just know that these are binaries you probably want to use, and don't mess around with it because don't mess around with this folder because OpenFOAM would still need to use them. Okay, great. I'm running out of time again, so I guess this is just the explanation part. All right. Alright, so it can look over here, it can look over here as well, under some platform dependent path. Okay, so you can actually put it in your own custom library. So I'll look at wm directory. So this is the wmake directory. You can go to rules, and I see wm arch. Okay, where is? Okay, let me echo wm arch to see what it is. Linux 64. So let's see Linux 64. Okay, there is no Linux 64 here, so to speak. But anyway, we can actually go and look there to see, one of the ways, and here is where you can also look for certain libraries. Okay, for example, let me look at Linux GCC. You can store a lot of library files here, but alright, and if you take a look at this, what does this look like? This actually looks like specific rules for compilation. So you can actually store some data here as well, but I'm not going to go too much in detail. Okay, you can even put other directories listed in the make options file. Okay, so where do you how do you specify these extra libraries or directories? You use this exe include So this is for your executable. You want to include certain directories. You give it this flag of I. Okay, this I here is supposed to tell you where your header files are, and this L is supposed to tell you where your library files here. Notice there's a capital L and a small l, so do note the difference. But anyway, that's for later. This will be your make files, and then under options. So you can see, if you want to include all your make files, include all your header files, this is where you'll do it. Then these are the libraries you want to include. Alright, so this is the syntax you use. Alright, so you have this one backslash. Okay, over here it uses a double backslash, but I will just follow whichever version of OpenFOAM you're using. Just stick with that. Okay, so if Buoyant pimpleFoam likes to use this version, I will just use this version. All right. Okay. So yeah, same thing for library. Blah blah blah. Okay, so I'll faster try and finish it off. Then call it a day, because I've been explaining the wmake process. Okay. Let's see. Anything else I want to cover? No, I don't want to cover all of this. It's way too much. This is the example using piezoFoam. I'm using Buoyant pimpleFoam as an example. Okay, so before I close, I just want to say what this other file is, what this files thing here is. Okay, this actually tells you which C file is your main file, your int main and return 0. This is where your main file is. And then where do you put the binary? Okay, the binary is put under this. You can specify this path under exe. All right, just like what it's saying here. You can define your path under this exe. Okay, so makefiles also includes a full path and name of the compiled executable, specified by exe equals to some syntax. All right. So OpenFOAM uses two useful choices for the path. One is called foam app bin, where all your default applications are. If you want your own custom application, you put it in foam user app bin, so you don't kind of mix it up, because these are the standard OpenFOAM ones. These are the ones you are like playing around with. So if you look at Buoyant pimpleFoam, we see that the executable is stored in the foam app bin variable, and it's going to be stored under the Buoyant pimpleFoam. So if you take a look at, let's just change directories to foam app bin. Okay, you'll see all your stuff here. All these are binaries: Buoyant Boosiness pimpleFoam, Buoyant pimpleFoam. So if you look at the Buoyant pimpleFoam, this is actually a binary. So basically, all your stuff, when you're running solvers, you're actually running it from this directory. So let's see. If I have all run serial here. Okay, I will just have this run application. Okay, and of course, for this particular run file, you actually run it from this run functions. But okay, basically, when you run something like a block mesh, okay, or whatever, it's going to basically look for one of these binaries here and run it. No, the stuff behind the scenes has already been done, but know that you're actually running binaries from here. Okay, compiled binaries. Okay, so this is roughly the whole workflow of how individual solvers are being compiled. Okay, so when you actually set up OpenFOAM, all of this is being done. So well, I'll call it a day before it goes too long. All right, so I just see you guys in the next video. Thanks for watching.